Hello and welcome. I am Cindy Cronenshield with Cambridge Health Tech Institute and the Executive Event Director of BioIT World Conference and Expo. We are excited to bring you Trends from the Trenches keynote session. The intent of this session is presenting and discussing the latest in data in scientific computing, trends and best practices. This tradition started with Chris Dagdigian only giving his State of the State address, which has now evolved into a State of the State address, followed by friends sharing perspective on relevant topics, then closing with an interactive moderated Q&A discussion. The BioIT conference would not be complete without this session. It's a popular annual tradition and we celebrate its 10th anniversary this year. 10 years ago, Trends was born. At that time, Chris Dag also appeared on the front cover of BioIT World magazine. I remember when that issue came out, BioIT World magazine was under the leadership of Kevin Davis, then who was the founding editor. He was also the founding editor of Nature Genetics and served as the editor-in-chief of Cell Press and publisher of Chemical and Engineering News. Kevin is the author of 4 popular science books, including Cracking the Genome, The $1,000 Genome, and an updated version of DNA, The Story of Genetic Revolution with James D. Watson and Andrew Berry. His newest book, Editing Humanity, was published this week. In 2017, Kevin won a Guggenheim Foundation Fellowship in Science Writing. That same year, he joined Mary Ann Liebert to spearhead the launch of the CRISPR Journal and joined the GEN editorial team. Kevin holds a degree in biochemistry from Oxford University and a PhD in human genetics from St. Mary's Hospital Medical School, London. He carried out postdocs at MIT and Harvard Medical School before joining the editorial staff at Nature. Our keynote session today will be chaired and moderated by Kevin. I thank you for being here, and I thank all of our speakers in the trend session for being here as well. Kevin, I hand my mic off to you.
Thank you, Cindy, and hello, everybody. Good morning. It's a great pleasure to be back at the BioIT World, obviously a virtual event this year, sadly, so we don't have the pleasure of running into each other and talking offline. But thanks to Cindy, Alison Prophet, and the whole BioIT CHI team for doing a great job in keeping the conversation rolling. As Cindy said, Trends in the Trenches has been an absolute mainstay of the BioIT conference for a very long time, and we're looking forward to spending the next 90 to 100 minutes in the company of Chris Dag and 4 brilliant experts from some great institutions to have a really robust discussion about their views of the current trends and issues in the trenches, particularly in this year, unlike any other year that we've experienced. So a fun and interactive and provocative discussion, I hope. It needs your participation, however. So we have obviously the chat box on the Zoom interface that you're looking at. Please, at any point during Chris's presentation or during the conversation as it continues to roll along, let us have your questions. I promise you we're going to take as much opportunity as we can to put your questions to Chris and the rest of the panel. So just as a quick interlude, as Cindy kindly mentioned, it's been a crazy week here in the Davis household with the publication of Editing Humanity. You might just see it appropriately posed on my bookshelf behind me. That came out on Tuesday. The Nobel Prizes in Chemistry, amazingly, yesterday were for CRISPR. Excuse me while the train just rolls by in my neighborhood. And then last night I find myself on Twitter having a conversation with MC Hammer, who assures me that he's going to be listening to my audiobook, which I narrated while he's working out. So it's been a completely bizarre beginning first half of the week. Anyway, back down to earth and back into the trenches we go. As Cindy mentioned, Chris Dag's Trends from the Trenches presentation has been a real or a quasi keynote feature of the BioIT conference now for more than a decade. And I vividly remember the first time we encountered the Bio team. It was the first year of BioIT World's existence in 2002. And 6 months into publication, a ragtag group of 4 bio IT professionals came and said, we've got similar interests. We should talk. And we put them in the magazine. I remember them posing for photographs like they were, I don't know, U2 posing for the back of an album cover or something. We thought, well, these guys look promising. They seem to know what they're talking about. And they sure did. For as our community has grown, so has the bio team. I think up to now about 30, perhaps even more. But Chris Dag remains one of the founding members and one of the linchpins of that group. And we've enjoyed hosting Chris at the Bio IT conference now for so long, really for 3 important reasons. 1, he's a very nice, humble guy. 2, he knows so much from his day-to-day experience about working with customers in pharma, in industry, in government, in academia, addressing IT problems and solving problems for the life sciences community. And 3, and most refreshingly, in a show like this where you're getting spin and hype and all kinds of messaging from many, many big companies, it's refreshing and essential that you have somebody who you can rely on to just cut through all the noise and all the spin and say, this is what's really happening. This is what's happening in the trenches. And Chris has fulfilled that function magnificently for well over a decade, as indeed do all of his bio team compatriots. So it's always a pleasure. We never know quite what direction the Trends from the Trenches is going to go. But for the next 30 minutes or so, you need to strap in, because you're going to be taken on a roller coaster ride of what's really happening in the bio IT world as the one and only Chris Dagdigian sees it. So Chris, it's a great pleasure and honor to introduce you again. We're really looking forward to your comments. And then as soon as you're finished, in about 30 minutes or so, we'll bring the rest of the panel in to reflect, give their own views of the trenches, and then we'll take audience questions. So Chris, over to you.
All right, thank you very much, Kevin. I really appreciate it. All right, let's start to share my screen here. And I'll rely on chat to let me know if you can't actually see anything, but in the interest of time, I'm going to move on. So for those of you who aren't familiar with the graphics background, I haven't actually been able to visit many data centers due to the pandemic. So all of the graphics for the talk today came from my pandemic island on Animal Crossing. So if you're wondering, that's where all the pictures are coming from. So the other thing that I've started to learn from doing talks this year is that people can kind of get a little bit burned out on Zoom, particularly if you're in all day. So we're trying a little bit of an experiment.
Yes, we can't see your slides.
All right, so let me go back here. Let me know if, that's visible now.
Yes, that's perfect.
Yep.
Okay, yep, sorry about that. So yeah, in the interest of time, we're trying a little bit of an audience interactivity thing. If you feel like going over to slido.com and entering the code TFT, you'll be able to participate in an audience Q&A, ask some questions. That being said, Zoom chat is still totally viable. And what we'll be doing is we'll likely be curating questions that come in via Slido, and we'll just be pumping them into chat as well so that Kevin only has one place to look. So just by way of interaction, this is the type of thing that Slido allows. We can sort of embed live polls, quizzes, and surveys into stuff. BioTeam has found that it's fairly useful when doing sort of live remote virtual sessions over time. But oh, look at that, someone just answered the poll. So I'm not gonna belabor this, just to show you that it's kind of cool to add sort of interactive data gathering stuff to a long talk or a long session. So I'm gonna skip the audience survey. This is just an example of embedding some of the Slido stuff into a talk. And by way of introduction, I actually don't think I need to do much of an introduction since Cindy and Kevin both did it. But yeah, 11 years ago, this was me. And unfortunately, I sort of created a monster. I think, like as others had alluded to, one of the reasons why the Trends Talk became popular is that the cool thing about BioTeam and our work is, you know, we're consultants. We're in and out of many, many different types of organizations every year. We get to see how similar groups of people, similar groups of smart people tackle similar problems. And so, and also many of our customers, many of our projects, we're allowed to publicly disclose certain things about what we see. So I think way back in 2009 and 2010, people sort of liked the blunt and honest. You know, I was fairly candid about the things I screwed up. I was fairly candid about the stuff I liked and I didn't like. And, you know, I think that was a relatively refreshing view for conferences where, you know, there might have been a bit of a marketing spin or, you know, that sort of thing. So that's sort of the background of why I've sort of been doing this for the last 10 years or so. And I'm trying desperately to pass the baton to younger, smarter, more accomplished people than me over time. And neither BioIT nor Stan will let me. So again, we accidentally created a monster. And again, this is now the 10-year anniversary, but everybody has gone over that and I'm already more than embarrassed. So I'm just gonna go through that very, very quickly. So the other thing is that because we're meeting virtually, we actually have the ability to bring a lot of our friends together. So I really want to highlight the sort of high-powered panel we've got. And my goal really is to sort of do my standard thing where I speak very, very quickly and stun you senseless with a ton of slides, but then get out of the way relatively quickly so that I can hand over to the panel and we can have more of an interactive discussion back and forth. So the way that I want to run this, the original Trends was sort of a solo act. I would do 90 minutes, I would slam 180 slides down your throat, and then we'd call it a day. But it's time now to sort of switch up the focus. I don't have a lot of time to do a deep dive into multiple topics. I could talk for 30 minutes about cloud or storage or infrastructure or GPUs alone, and we simply don't have the time to do that in our forum. So what I'm actually going to do is change it up a little bit. I've got a couple of sort of very quick hit topics to cover. I'm going to talk about some of the drivers that are changing IT and infrastructure this year in 2020. I'll talk a little bit about the hype warning for 2020. And really, I'll be candid about all the stuff I got wrong last year in the Trends talk. And then I'll take a slightly deeper dive, spend a little bit more time in the talk on just one major topic area. And both because it's a major focus of our consulting work, but also because of the makeup of our panelists, I've chosen this year to focus on storage and sort of data management and data exploration and data insight topics. And so with that said, let's be going. So the first quick topic that I want to cover is really, what are the scientific drivers that are stretching and altering sort of IT requirements, architectures, and needs over time. And the following couple of slides I'm going to show you is really a distillation of multiple bioteam consulting engagements over the last year. And so just to be very clear, this comes from bioteam. This is not my work. There's a ton of really, really smart people producing really good information, and I'm lucky enough to be able to plagiarize their work and stick it into my talk. So, starting from the sort of first and original driver, we still have genomics and bioinformatics. Historically dominant and still very, very large player in the infrastructure space, particularly because sequencing just keeps getting bigger, faster, cheaper, and more accurate. And every time that happens to an instrument, you see sort of a reset in the type of scientific questions and the sort of depth of scientific exploration that's undergoing. The IT impact for genomics and bioinformatics, though, hasn't really changed. It's really about having enough storage capacity, petascale in many cases, and having a mix of large memory, regular memory computing. And also a lot of the IT and infrastructure challenges around genomics right now involve actual data movement and data capture, because the source of our genomic sequencing information is coming from all over the place. It's coming from the edge of our enterprise over the network, but it's also coming from outsourced CROs and data providers and things like that. If we move on to the second biggest driver, this is actually the fastest growing IT driver that Bioteam has really ever seen. It's really interesting. If you do a storage audit or storage analysis in a scientific computing environment, particularly in sort of a data intensive life science organization, the dominant file type is now images. The dominant file type used to be reference genomes and genomes. We're now clearly seeing that the fastest growing driver, and in many cases, the dominant type of file, is actually image. And so what that actually drives is, it drives, again, an interest in storage capacity. We're starting to see a little bit more focus on the performance of storage, because image-based workflows tend to be fairly I/O bound if they're not memory or GPU bound. Definitely, this is where GPUs come into play. There's a lot of the analysis workflows, particularly for cryo-EM, that quite a bit of the analysis is offloaded to GPUs. And then finally, the images are just as big and coming just as fast as genomes and genomic data. And so again, from an IT and infrastructure perspective, there's a renewed focus on the speed of our networks, the cleanliness of our networks, and how are we doing large-scale data ingest and data movement, both within the organization and through firewalls and to and from various clouds and collaborators. Machine learning and AI is actually the toughest thing. So the problem that we have with machine learning and AI is that with the other types of science drivers, as an IT person, I can often make trade-offs. I could have an honest conversation with bioinformatics people and say, look, I can give you a giant storage system, but it's not going to be the fastest system on earth. And so they would make a trade-off because they needed capacity and they're willing to run a little bit slower, or maybe they weren't even I/O bound. The problem with machine learning and AI is that it is radically changing the storage that we design for biotech, pharmaceutical, government, and EDU. We now need to have storage that is both very, very fast and very, very big. It's tough to have a thin wedge of really fast performance tier and then a bigger wedge of nearline and a bigger wedge of archive, because in machine learning, you're constantly going back and you're training and retraining your model against both old and new data. And so if you look at the I/O usage patterns for machine learning and AI, not only do they need very, very fast storage because they're actively analyzing new stuff, but your storage namespace or your storage platform needs to be very, very large as well, because they're often reaching back in time and they're constantly rerunning against older data. And so that's probably the biggest IT challenge that we have right now as the rise of machine learning and AI. I used to be able to save money by picking one, big or fast. Unfortunately, with ML and AI, I need both. I need big and I need fast. And that's why you're seeing some relatively interesting movement in the storage space in life science. There's some historically dominant, scale-out NAS vendors that are have some competition now, and it's fairly sort of interesting to see that in the real world. And then finally, chemistry and MD is interesting. Again, the focus there is really far more CPU bound and GPU bound than storage bound. It's also a particularly good sweet spot for moving to the cloud, particularly if you don't have latency sensitive or 3D sort of information to sort of deal with. Interesting data point, I was looking at the sponsors today and really just looking at, so this is all of the sponsors that we have for BioIT World right now. If I subtract out and just try to highlight the ones I think of are explicitly storage players, there's still a really interesting mix here. And then if I look at the ones that are explicitly here and offering a data management, data analysis, data movement, or sort of data exploration service, we have another set of vendors. And if I combine the two, we actually have a fairly interesting, solid majority of BioIT World spenders are playing in either the storage or the exploitation of knowledge space. And so it's notable because the focus of this talk is really data and data management, so I think it aligns. But also, this means to the audience here that if these topics are of interest to you, there's a lot of really interesting vendors that you can go talk to. And I'd encourage you to sort of take advantage of the conference, virtual trade show booth, virtual expo floor hall. Every one of these vendors here would be happy to chat with you and sort of answer questions. So that was sort of the scientific drivers. That was kind of a recap of things that are sort of driving IT and infrastructure in our consulting world. And basically, the type of science that you do influences the type of IT and infrastructure that you need. And really, it's irrelevant whether it's cloud or on-prem. The stretches are the same, regardless of the location of the compute or the storage. So moving on a little bit on sort of puncturing the hype curve. Every year, there's a new bandwagon. Every year, there's a new hype thing. And every year, we try to puncture the hype a little bit. And so I really wanted to sort of punch this up. And so I'm going to sort of title this as what are vendors most likely to lie about in 2020 and 21? And many of you can probably guess the answer, but it's machine learning and AI. In every purchase cycle, there's breathlessly overhyped product. There are manufactured reference cases, things that really don't add up when you sort of read between the lines. And so the machine learning and AI space has been like this for a long time. It's basically creeping in as a buzzword into every product sheet that you can imagine now. And also that last bullet point there, I don't know why, if it's because they hire super aggressive salespeople, but when you're dealing with the super hype products, that's also when you end up with kind of a really creepy and unprofessional sales cycle. And I like to call that out when I see it. And yeah, there's a lot of tech bros doing weird stuff in the ML and AI space, particularly trying to sell to you right now. That being said, I want to be absolutely clear that unlike blockchain, machine learning and AI is actually useful. These methods are real, beneficial, and sort of driving real significant transformation in life science. So the issue here is you've got to apply your sort of conservative cynicism to sort of filtering out what's realistic and usable to you versus, what is kind of wrapped up in sort of a big fluffy marketing ball from someone trying to sell you stuff. So just be cautious, test the reference cases, make sure it's not a fully manufactured reference. And then the other big thing is the way these products are sold. Machine learning and AI is probably something that needs to be driven from your engineers and your scientists at the bottom up, because there's a lot of decisions that need to be made about what does your tooling look like? What is your workflow? What inference engine are you going to select? What framework are you going to choose? What GPU family is most efficient for the type of work that you're doing? The problem is that the sales cycle is often focused on selling to the senior people. They're selling into the C-suite or trying to sell into the board. And so you've got to manage a little bit of expectations where you might be getting pressure from senior management who are trying to push a very, very large ML and AI push down into your world, when in reality, it's actually the scientists and the engineers and the software developers down in the trenches who probably should have a little bit more say in those decisions. This is one of those topics where I'm sort of uncomfortable seeing the selling into the C-suite pitch. I think that the sales cycle needs to target the end users and the scientists rather than the IT and scientific leadership. So that was kind of the hype thing. Moving on a little bit to sort of scientific data here. The reason why I wanted to sort of concentrate a little bit more on data and data management topics is listed really here on the slide. One is that, petabyte scale storage has been easy for a long time. Managing and understanding the data that you have is still the single hardest problem I have in sort of the BioIT spectrum. It's a significant amount of our consulting work every year. And finally, we are seeing the limits of what can be done with scale-out NAS. We're seeing the limits of what can be done with tiered storage or automated policies and things like that. And then finally, the rise of ML and AI and its stresses on storage, including Also, the image-based acquisition are sort of radically changing the sort of fundamental baseline requirements I had for designing and speccing out storage systems for research computing environments. So these are all of the reasons why it sort of makes sense to sort of concentrate on data storage and data management topics in this sort of shorter session. So our focus on scientific data, the problems we have is that we've got big data, we've got siloed data, we've got dirty data, and we've got biased data. And I'll try to talk a little bit about each. So the issue with big data here is, you know, if you listen to me, and you're probably tired of listening to me after 10 years, I used to say a lot of stuff, you know, like it's far easier to acquire or generate data than it is to efficiently store it over its full life cycle. It's also been, you know, I've said this repeatedly, that although storage is decreasing in price, it's not decreasing fast enough to compensate for the rate at which we're acquiring, generating, or downloading new data. The issue here is in 2020, cryo-EM and sort of image-based workflows have sort of blown that out of the water. The issue that I'm really seeing here now, and this is where I'm going to be blunt and sort of call out failures in scientific leadership and IT leadership, is for too long and for too many years, leadership has avoided having uncomfortable questions with scientists about data stewardship, data management, and data organization. Rather than have that uncomfortable conversation with scientists, they've just thrown money and made their storage systems bigger. And we're now seeing some fairly problematic limits with this style. And I will reiterate, this is absolutely a failure of IT and scientific leadership. They are adverse to difficult conversations with scientists, and those problems are now coming back to bite them. So the other issue here is, I used to say, you know, if you had a petabyte of storage in your organization, you were at the level where if you didn't have a full-time human being managing and curating your data, you're wasting more in CapEx dollars than the cost of that human being. The flip side here is I've now seen multiple organizations with many petabytes of data who have no curator, no standards, no governance, no quota, and no policies. And so we're now, I'm sorry, I used to say, you know, at 1 petabyte, you need a human. Clearly people disagree. I'm seeing people with 10, 15, 12 petabytes out in the field, and just a long history of just absolutely ruddership leadership when it comes to sort of organizing, managing, and sort of curating that data. I really do think, you know, I used to say in the years past, you know, data triage was okay. You know, we've in genomics in particular, we've gotten comfortable with deleting data because we can always go back to the -40 freezer and rerun the experiments. We have a history of our instruments getting better and more sensitive and being able to run the samples that we have. You know, typically people are a little bit more comfortable with throwing away old data because they can either regenerate it or they can rerun it. I'm also very, very well known for being very blunt and stating that it is wildly inappropriate for IT to have a say in scientific data management decisions. Any data deletion, any data triage decision has to come from science, and it has to be governed on the science side. It's really, really inappropriate to bring IT into the mix here. So it's a difficult thing to manage. But, you know, if I contrast that to stuff that I'm seeing now, just broadly speaking, collectively, we've sort of failed at this. I think, you know, the time now is new and sterner methods are going to be required. There are some intractable problems, and you really can't throw money at the issue anymore. You can have as many petabytes as you want, and your scientists will always find ways to fill it up. So we really, really, really now need to be talking about data management, data stewardship, and data governance. So I'm trying to create a new trend in 2020, and this has sort of permeated my consulting work over the last year. I really want to push a culture change across the life sciences and realistically sort of push across the point that storage needs to be treated just like any other lab consumable. You need to justify it, you need to budget for it, you need to plan for it, and you need to be able to defend that to your leadership. And I think that it needs to be actively managed by both science and IT. And one of the ways that, you know, you're starting to see trends like this sort of manifest in the real world is, this is coming from NERSC, and I've got a slide coming up about, but I really, really like it. One of the single biggest issues that we've seen is sort of unrestricted growth in people's home directories and personal folders. You end up with data attribution, data versioning, even data fidelity questions. And so one of the really interesting trends we're starting to see here is nobody gets large storage anymore. Nobody gets a personal folder that's giant anymore. All storage allocation is handed out on an experiment or project basis. And that single change alone is driving really, really interesting and positive changes. No more giant home folders. All storage has to be allocated or binned out and assigned to either a project or an experiment. And you organize at that level from the top down, and it works out a lot better. You have far less islands of data where you really don't know what's going on and what that person has done in their home directory and how those permissions are constructed and everything else. So this is just an example, you know, just trying to show you that this is out there in the real world. It's really interesting. I like reading file system and other acceptable use policies at supercomputing sites and other sites because, you know, the people who have much larger infrastructures than us that have much bigger problems to solve, none of this is rocket science. Other people, other industries have solved the same problems that life science has. So I'm looking at things like nurse and I'm like, wow, okay, you flat out don't get more than 40 gigs in your home directory. You flat out don't get more than 1 million inodes. That's the type of sort of practical, sort of real policy-driven stuff I like to see. Again, NERSC is doing this because all of their storage allocation is dedicated to something that's not a personal home directory, basically. If you've got big data, you got to put it somewhere else other than your personal folders. So moving on, talking a little bit about siloed data, the issue here is, collectively in the early days, in the 90s and early 2000s, we used to be able to centralize compute and storage. We could put it all in one data center. We could bring the users in over a VPN or a remote desktop session. That really doesn't fly anymore. Data-rich environments are sort of diffused throughout the organization. They're at the network edge because we've got terabyte-scale laboratory instruments and satellite offices. We've got data sources that are all over the world, from collaborators, outsourced data providers, CROs. And it's not just static files anymore. It's not images and genomes. It's events, it's documents, it's IoT, it's time series sensor data coming off of bioreactors, all sorts of sort of rich data types that we have to capture, analyze, and manage. And finally, the last bullet point is significant, is that there are now petabytes of really interesting open access data that would be completely viable for a scientist to want to download and bring into her working environment. So IT now has to sort of deal and game out and plan for the fact that not only do we have to deal with managing storage, compute, and analysis for our own internally generated data, we also have to sort of carve out the ability for our scientists to bring in really just truly vast amounts of public domain data down so that they can be sort of integrated and computed against and, analyzed and exploited. So what we're starting to see here is, from the infrastructure perspective, this means, again, BioTeam is doing networking. We're separating science data from business networks via science DMZs. We're starting to see more 40 gig and 100 gig networking segments being run inside companies. We're starting to see a lot of compute, or at least initial compute and transformation happening at the edge before it sort of goes into the central scientific analysis environments. Data lakes are interesting. For every awesome data lake project, there's probably a dozen or so sort of embarrassing failures that are sort of hidden away and no one really talks about anymore. And then finally, the really interesting thing here is the trend around data platforms and data commons. And just to highlight, BioTeam has sort of settled on the open source Gen 3 stuff. And I left a couple of URLs in there, but one of the other things that's interesting is I just did a quick hit through the agenda at this particular conference, and there was at least 3 talks alone, and I might have missed more on Gen 3. And the cool thing is all of them are available on demand and they're recorded. So if Gen 3 and Data Commons is sort of interesting, definitely take advantage of the conference platform here and go check out some of those talks. I think most of them have already happened. There might be 1 or 2 happening more today. Finally, sort of transitioning into dirty data. So the issue that we have here is, and I've seen this personally, I'm not going to tell you my age, but in one career generation, I've gone from sort of tracking data in a scientific lab notebook in a wet lab to sort of petascale data wrangling. And so generally speaking, we've scaled up our storage capacity, but we've ignored or underinvested in everything else. And that's governance, curation, metadata, data cleaning, SOPs, and standards. I've already repeated myself here, but I will say it again. The blame lies with scientists and scientific leadership. IT can't make these decisions for you. It's on you. It's up to you to clean up your stuff. It's up to you to manage your data. And we're starting to see the effect in our consulting work of years or decades of neglect of storage management. And it's becoming very, very sort of painful to deal with. It's also going to mess up a lot of ML and AI work because the accuracy of your ML and AI depends on the cleanliness and organization of your input data. And frankly, from what I've seen out in the field, it ain't that clean and it ain't that organized. So there's a lot of work that needs to be done. So moving on a little bit to the other big thing with ML and AI in particular is the problems of sort of biased data. And so, we as scientists, we as IT practitioners, we as people who are sort of involved in data intensive science, with a healthcare or mission to improve, human lives and human outcomes, it's our responsibility to ensure that this is handled responsibly. We've had clear failures with data hygiene. We've had clear failures with biased models. And it's really, really sort of up to us to make sure that the mistakes that other industries have made with ML and AI don't continue to percolate into sort of data intensive life science or sort of discovery oriented scientific research in general. And I suspect the high powered panelists that we've got here have probably got some interesting things to say about this as well. So moving on, I want to hit the other quick topic here, all the things that I've screwed up in the past. And so this is where I can sort of candidly go back on things that I said in 2019 and, tell you what I got wrong. The list of what I got right, I think, is much smaller. So it's easier to go through what I got wrong. All right, so this is sort of a short summary of things from past trends, and I've just got a slide on each of them, so I won't stick on this particular slide. So compilers matter again. So there was some interesting time when BioTeam was doing a lot of work with cryo-EM workflows, in particular figuring out that there were actually very significant performance differences depending on what compiler you use to build your open source scientific software. We saw significant differences, and we thought that those differences would justify a lot of investment in compiler work and optimization. Absolutely wrong. You know, I was expecting a bunch of interesting consulting work involving, you know, compiler and application deployment workflows, and pretty much none of that happened in 2019-20. I think people are still using, you know, the standard tools, or they haven't really sort of changed up what they're doing with respect to compilers. The other thing is that, you know, last year it was abundantly clear, and it's become even more clear now, that Intel has some very, very serious competition now. You know, there's really not a clear answer to AMD EPYC for a lot of use cases. And so I also expected in my infrastructure work to expect, you know, I was expecting to do a ton of, you know, AMD versus Intel benchmarking, helping people make procurement decisions, especially as if you look at where the exascale supercomputing bids have sort of gone in the last year or so, you know, there seems to be a clear trend here. But again, this is something that really sort of never materialized. It might have materialized elsewhere. So again, being honest, you know, this is from BioTeam's consulting experience. Just never really saw a lot of compiler work in the last year or so in terms of our consulting work. Although I will say, you know, now in 2020 and 2021, it's not just AMD versus Intel. You're starting to see, like, particular, if you look at the price differences on Amazon for the ARM64 options. So I'm not sure if I'm gonna, you know, stand here and say that compilers or CPU stuff matters again, but the diversity of choices is even more beneficial now, or even more significant in 2020 and 2021 than it has been in the past. The other thing I used to talk about was I really wanted policy-driven automatic tiering storage, and I've completely changed my mind on this. I think what we found in the real world is that IT managed automatic tiering of scientific data based on some arbitrary policy like file age or last access time is really not ideal for our world. I've got some more stories about the time a 12 petabyte file system decided to archive all the batch RC files. Again, having IT or an IT administrator control the tiering process is not a really good fit for scientists. And really, I think what I wanted to say is, and you know, I knew this for a long time, it just never really manifested in my thinking about storage and storage management. But the fact is, if you talk to a scientist and if you sit down with her and you ask her about how she manages data, it's very, very clear that scientists work on a project basis or an experiment basis. So rather than archiving or tiering based on file access time or age, which is not really good for scientists who often need to go back and reanalyze old data, you know, to hit a publication requirement or something like that. What scientists really need to do is they need to make storage and storage management, and particularly tiering decisions, based on project or experiment. And again, that puts you clearly into the world where you're outside of what the sort of policy engines can sort of do in the standard projects. And we've got to give more control over the storage management to the scientists, because that policy-driven stuff based on artificial metrics like access time and file age, it just doesn't align with the way scientists work in the real world. So what I'm really pushing for and what I'm really looking for when I evaluate storage platforms is I'm looking for storage platforms that either offer really intelligent policy-based decision-making, or more ideally offer user self-service. You know, allow the user to tier or archive a giant directory without opening a help desk ticket. You know, if she could just right-click and send a nearline, you know, something like that would be ideal. Finally, I also talked about single global namespace. This is where I am going to get a little bit salty. You know, from an IT perspective, a giant single namespace storage island is fantastic, because the less data islands you have, the less data duplication you have, the less questions you have about data provenance, or, you know, what's the, you know, is this really the reference file that we should be using or not? But what I found, and this goes back to what I've, you know, said before, where, you know, years of real world data just kind of shows that, you know, end users are not really responsible stewards of the storage when they've been given a giant single namespace environment. And I'm going to be salty here and say that I'm really tired of hearing whining from scientists who built their entire career on publishing and you know, being known for working in data intensive science, having to whine about sort of actively managing and make data, you know, data-driven decisions about their data. I'm going to be clear here. You know, as an IT person, I'm done. You know, if your career is based on data intensive science, I don't want to hear you whining about the, you know, the onerous burden of managing your data. That's your job. That's your job. You know what? Do your job. And it's starting to get fairly problematic in this space. And again, it's really coming back to just, years and years of irresponsible stewardship and years of sort of failure of scientific leadership and IT leadership to have those difficult conversations with scientists. And now we're starting to see the problem. We literally do not have the budget, or we literally do not have the capacity to grow the storage to the rate at which the scientists won't consume it. So we actually have to have these difficult discussions, and we actually need to put the control back into the hands of the scientists. All right, oddly enough, that's actually the end. And if I look at my timer, I actually ended with a few extra minutes to spare. So what I'm going to do here now is I want to thank you for your time, especially those of you in East Coast time, or sorry, West Coast time zone, where it's still, you know, very, very dark right now. My goal right now is I'm going to shut off my camera, put myself on mute, and hand it back to Kevin. And again, thank you so much for your time and attention. Thank you for the opportunity for being able to speak with you today.
Thank you very much, Chris. My camera will come back on momentarily. Okay. Chris, that was a wonderful talk, not surprisingly, and on time as well. We did have one attendee ask if you could speak slower, and I responded, I don't think you have that gear, but that was brilliant. So what we'd like to do now is bring in our other 4 expert guest panelists. All could have given, not quite with the same elan perhaps, but all could have given an equally riveting trends in the trenches from their own unique perspectives. So they're going to react, and I want to hear from them both what's it like in their trench, as well as what the impact of COVID-19 has been in their particular environment, or perhaps even in a broader environment. So we'll start with Vivian Benazzi, who left the NIH fairly recently, in the last year or two, I believe, and is now at Deloitte Consulting. So Vivian, great to see you. Give us your view from your trench.
Good morning, yes. Can you hear me okay?
Yes, we can, sure.
Perfect, thanks. Well, welcome everyone, and thanks for the introduction, Kevin, and also a great talk there from Chris. So, purpose of today is for each of us panel members just to give a little bit of a view of our trenches. So I'm going to try and give you a little bit of that. So just a little bit about me, just to give you the context of that trench I'm going to talk about. So as Kevin was just saying, I spent the last 12 years at NIH and just recently and left to join Deloitte. My role there is to look at how organizations, biomedical, government and non-profit agencies use biomedical data. What are the issues and how do they solve those? So our work involves work with NIH, FDA, CDC, all of those big, large government organizations, and also a collection of non-profit biomedical organizations as well. So I'm just going to talk a little bit about the issues that I'm actually starting to see. And I'm going to set my timer here to make sure that I can do what Chris did and stay on time. So I saw in this conference, but also with a lot of our clients, there's the concept of a data ecosystem. I've heard this term a lot, and it means many things to different people. The way that I tend to see it is it's what is collectively needed in order to openly and securely access, share, and use data or multiple data sets. Much work is happening on this particular field in both individual components as well as components as they fit together. I think we saw a lot of the talks during this week that cover various of those components. So what do I mean by that? I think an ecosystem covers two broad areas, and I'm sure there'll be many details you can fill in here, but for time, I'm just going to give you a broad brush. One of those is the data itself. So all of the pieces that you need for the data to be useful. So all of the metadata, the data harmonization, the common data elements, the standards, the best practices, the governance models, and the data models. All of that is being discussed as either components or collections of components. So we're starting to understand the intersections. The other part is the supporting infrastructure. I think Chris talked a lot about this, which is the hardware and also the software that supports the ability to do all of that stuff with the data. So we need to look at the hardware. We talk a lot about cloud, but that's not the only option. We look at data wrangling, what you actually have to do to clean your data, which is we have to spend a lot of time and issue with it, the automation and the analyses that go with this. All of these components come together to form the ecosystem. And I think what people are talking about is individual components, but putting them all together is quite hard. So what we're noticing with a lot of the people we work with is how you would operationalize such a thing. And we're seeing it in two forms, and there's a little bit of blurring between these two terms that I'm seeing, but I think we're also getting towards the fact that we're moving into a dynamic world with data. So the one that I want to bring up is data platforms and data commonses, and Chris finished his talk by talking about data commons, so I'm glad that all intersected there. So I want to talk a little bit about both of those, data platforms and data commonses. This is just my perspective of what I see from clients, and also I'd spent a lot of time working on data commonses when I was at NIH, so a fairly strong background in that. The data platforms tend to be these end-to-end solutions that often can result in silos. It's quicker to actually do this because you actually want to analyze your data and get to an end solution to what you want to do. They're often proprietary, but not always. But I would also say this is where the blurring is occurring. Some of these systems are also moving towards using more open source and open standards in it. So although they might have been proprietary, they're now moving to some of those. The systems are native to themselves in the sense that they use their own data ingestion, their own data organization and management pieces, which are not consistent in any standardized form for others. So it can be a little complicated to understand how that's done. And they're not designed really to integrate well with others. They're designed to solve a series of problems. And that is causing some of the issues that we see, and I'll speak about in a minute. The other side is the data commons. So this is another approach to looking at operationalization of data ecosystems. They tend to be more open and flexible. I think we heard it with the Gen 3 discussion that Bob Grossman gave, and I think Chris was talking about too. Open architectures that reuse open standards, open best practices for data and software. And the emphasis is on open and flexible. And it's more about integration and interdependence, because I think we and a lot of the clients we work with are realizing that just creating these lovely silos or cylinders of excellence don't work together. And as data becomes larger and we need to work across data sets, we really need to figure out how these systems can work together. So in the couple of minutes I have left, I want to just talk a little bit about some of the issues that I see with the folks that I work with. So as I mentioned before, I work primarily with biomedical government organizations, and I also work with biomedical nonprofits. The issues I see is organizations, they're both issues as well as potential solutions here that I'm going to say. I think organizations are more focused on data and the use and reuse of that. They're talking much more about fair and best practices. And Kevin was talking about the use in the world of COVID. What we're noticing is because we have to be able to share data much more effectively and efficiently in this time of COVID, because we want to get to a solution for therapeutics and vaccines, it's forcing this kind of data sharing conversation much more at the front and all of the pieces that go with it. So I think these are really good positive things. Some of the downsides of that is different parts of the organization see it in different ways. And it really depends on your background and where you sit within the organization in terms of often the level of seniority you have. So the usual things that we see is obviously there's IT, there's leadership, there's data science groups, data groups, there's biomedical science groups, and a collection of others. When each one of those sees a different part of the elephant, it can be a little hard to figure out what the solution is. And they really need to think about coming together to figure out how to solve it. I think COVID has reduced some of those barriers because we all collectively need to find a solution to help us overall as a human race. I think for leadership and of large organizations, although they're cognizant of these issues, for data issues, what they're finding it hard to do is they don't quite know where to start, and they're hearing different voices from different people. And that's true because each one comes with a different perspective. Many of the organizations are using data platforms, but they're realizing that they're creating many silos inside it, and they're not as willing to buy or use these data platforms as they were in the past. Just a quick shout out to what Chris was saying. We're absolutely seeing a lot of AI and ML hype, and figuring out how to use that is really imperative. Lastly, I'll just finish with some things that I think are real positives in organizations. I think we're finding more organizations asking us about data strategies, how they should think about things holistically. They're looking at data governance models for their whole organization and realizing that they should not try and do the whole, bite off the whole, or chew the whole elephant, so to speak. So they're looking at small places to start. They're looking at ways to think about how do you approach it as an overall data governance piece? Where do you start? How do you look at these pieces in a meaningful way that can bring all parts of the organization together? And I think they're also, which I think is a real big plus with these organizations, also looking at how you create incentives to share data and to look at where inside their systems those incentives have not been, but trying to improve that. And I'll stop there because I'm right at 6 minutes and pass on to the next person. Thank you.
Thank you very much, Vivian. Great remarks. So don't go anywhere because we'll be calling on you with the rest of the panel as soon as we get the whole group together. A reminder for the audience before I bring in the next panelist: we want your questions. We've got plenty of time, and I want to devote that time to your questions, not my softball questions. So let's get those rolling and use the chat on the Zoom feature. Anything technical, anything specific, your own problems or something more abstract or general, it doesn't matter. We'd love to hear from you. Okay, let's go over the pond to Tim Cutts. Tim Cutts is at the Sanger Institute. I think they dropped the Wellcome Trust bit of the name, didn't they, Tim? But
Trust has gone, Wellcome is still there. So we are now the Wellcome Sanger Institute.
Facility. That's great. So this is the flagship Genome Center, of course, and much more in the UK. And Tim, same thing, 5-6 minutes. Please let us know what are the trends that you're seeing in your particular trench, and if COVID is having a dramatic impact on things, we'd love to hear about some of those experiences as well.
Sure. So first of all, I mean, thank you very much for inviting me. I would love to just basically underline almost everything that Chris said, especially around data management in his talk. I think in particular, I absolutely 100% agree with per project assignment. Like many organizations, we have vast amounts of data sitting in people's personal area. Now, not actually in their home directories. We did actually, sort that out and give people a quota of almost 0. But nevertheless, the scratch file systems and so on are still pretty much complete chaos. So we are actually in the process right now of migrating to a entirely project-based structure, which is going to be painful for the scientists, but they are just going to, as Chris said, they are just going to kind of have to suck it up and live with it. We have to do it. I also wanted to pick up one thing that I was mentioned here about sort of siloing and data platforms. That echoed with something that one of my scientists said to me the other day. We were talking about how some of these large data sets are being published now through services in the cloud and elsewhere. In a way that's effectively behind it may not be a literal paywall, but it effectively is. And Sanger and the Wellcome Trust have a lot of collaborations with people, particularly in, for example, sub-Saharan Africa. And there was just a little bit of concern from this particular scientist. I thought this was interesting, that might actually, that kind of siloing just behind something where you have to pay, to some other provider to analyze the data where it is, might become a barrier to its use. So I thought that was an interesting comment. What's it like actually in my trench at the moment? I think, so actually the COVID pandemic is a really interesting way to look at where things have worked well for us and where they haven't. So although we haven't used the public cloud particularly heavily, we've been quite big fans of cloud computing as a paradigm for a long time, and we've been using OpenStack fairly heavily internally for some time. That worked extremely well in very short order, converting the institute from basically doing its regular science to shutting the place almost completely down, apart from a handful of scientists and lab technicians whose job it was to turn the entire sequencing facility over to COVID-19 sequencing. We're part of the UK's COG UK COVID Genomics project, and that was incredibly successful. The ability to run containerized pipelines, standardized pipelines in languages like Nextflow and so on worked really, really well. We had the NCOV-19 pipeline running inside a week, and we could just fire up the sequencing and get going. It is a fairly daunting prospect, I have to say. Basically, I don't know how many of you know, but the UK basically has 5 or 6 what they call Lighthouse Labs, which are doing the testing for the entire country. They're actually starting up a few more now, but there were 4 or 5 to start with. They send us all of their RNA extracts. We are currently sitting on a stockpile of 8.5 million RNA extracts. Obviously, we can't sequence all of them, and most of them aren't positive anyway. But we're currently looking at a capacity of we're sequencing 4,000. I think it's about 4,000 COVID genomes a week at the moment, but it'll go up to 30,000 a week across the entire consortium. That's been working pretty well, but where hasn't it been working? Well, I spoke to one of the scientists who's involved in it, and it's exactly what we've just been talking about. Metadata is the problem. We don't actually see much of the metadata at Sanger. We're sent effectively anonymized samples. We sequence them, we send them back out again. And we publish that data to a service in the UK called CLIME, which is a collaborative OpenStack environment for microbial informatics. But the metadata has to come in from all of the places that actually collected the samples, and coordinating that has been fairly tricky by all accounts. And they really did bring into sharp relief how that stuff has to be right. Data management, I've kind of mentioned that already. We're fine in the whole automated part of our large scale pipelines. It's downstream where the scientist works that I think we need work. Now, I mentioned that we're putting in some policies to sort that out. But what we could really do with, and I would love to hear anybody's ideas about this, is tools that really help the scientific user make those decisions quickly. So, how do we make it easy for them to annotate the correct metadata in an automated way? How do we make it easy for them to make that decision of whether that data stays or goes without it being a massively burdensome thing? I mean, we've used iRods for our bulk data storage for the automated processes, but that's not generally used by the end scientific user. So there's still a hole there, I think. I think that's pretty much all I was going to say. I'm just checked I took some notes earlier whether I wanted to make any comments on what others had said earlier. No, I think that's probably everything I wanted to say. So I'm happy to pass on to the next one.
Great, Tim. Thanks. We'll definitely have some questions for you in a few more minutes. So keep your questions, please, coming in through chat or Slido if you are viewing that, either one. And we want to hear from you. That we've got a few good ones that we'll get to in about 10 or 15 minutes. So stay with us. We've got 2 more panelists to bring in and get their own perspectives before we open it up for conversation and discussion and questions. I'm going to go now over to the West Coast for our next 2. Hopefully the air is now a little more breathable than it was in the last few weeks. So not only with a pandemic to deal with, but terrible wildfires all over the West Coast. So anyway, it's great to welcome Kirsten Fagnan from the Lawrence Berkeley National Laboratory. Kirsten, please say a little bit about what you yourself and what you do for folks who may not know you. And it's great to have you on the panel, and your timer starts now.
All right. Thank you. And I can't tell you what's going on with the smoke right now because it's still a little dark outside. So you'll have to excuse those of us on the West Coast that are just kind of slowly waking up. So I work at Lawrence Berkeley National Lab, as Kevin said. I'm the CIO for the DOE's Joint Genome Institute, which for those of you out there who might not know, the Department of Energy was actually heavily involved in the Human Genome Project back in the day. And that was, I think, a great example of interagency collaboration. And now I'm also the infrastructure lead for the National Microbiome Data Collaborative, which is a new project that's been sponsored by DOE to attempt to address some of what's been discussed around data management and data accessibility issues for microbiome data, with a focus on the Department of Energy, but we're hoping that we can actually incorporate data and collaborators from other agencies as well. So a couple of things I was thinking about when Chris and Vivian and Tim were talking. We got asked, to kind of think about this in the context of COVID. And one of the things that Vivian mentioned that I think is pretty interesting is how COVID has really driven collaboration. It's really been a source of breaking down barriers between different organizations, different scientific groups, because we're really feeling motivated kind of as a species to solve this problem. And it just got me thinking about why this doesn't happen more often. We talk a lot about some of the challenges in collaboration, challenges around metadata, challenges around the data that's being generated coming from a number of small laboratories across, across the world, really, now that data generation in biology is just getting easier and easier. But there's not the same sort of focus on taking a data set that you've generated and thinking about how to put it into context for everybody else to use. And why not? Why can we do this in the case of COVID, but we have all of these other scientific challenges that we claim have a need for team science, have a need for collaboration, and yet all of the responses and all of the proposed solutions seem to come out of these siloed efforts. And maybe that's a little bit dramatic, but that is definitely the way that it feels. So are the other problems we're tackling really so big they can't be done by a single lab? And if that's the case, it really doesn't seem to be how we behave or how the incentives are structured. So team science, collaboration, fair data, these are all concepts that really resonate with people. I think humans really like the idea of collaborating and things being fair. We really like fairness. They sound nice, but the reality is our process, our training, our funding models, our incentive structures don't actually support these ideas. They don't actually support you going and working with somebody else, because at the end of the day, you're going to be measured against your single author, first author, last author publications to get your next round of funding. So your survival is actually contingent upon you making sure that your lab shines. And it's been nice to see that get checked in the times of COVID. And I wonder what we can do to actually use this as a moment for culture change within science. And that might just be kind of an impossible goal. But as long as that feels impossible, as long as we, have all of these structures in place that actually support the creation and maintenance of silos, then we're going to have data silos or cylinders of excellence. And we're really going to continue to behave as though we believe we don't need others' help to get our work done. And maybe that's true, but it should shift our conversation. So we can talk about how bad silos are, but I don't think that we spend enough time discussing, the root causes for why they exist, or why it would be better if we didn't have them. Like, what are the critical problems out there that we can't solve because all of the data is siloed? So the other thing that I wanted to touch on is this idea of data management and data cleaning. I feel like, this is a growing challenge, but we also have this corresponding growth in data standards. So it's like that XKCD cartoon, I've got, there are 14 data standards that exist. I'm creating yet another one that I think people are going to use, but we don't stop and say, well, why aren't people using the 14 data standards that exist? And probably because it's annoying. Probably because sitting down and actually curating metadata and doing careful metadata assignment of values to several hundred keys is actually pretty painful. And it doesn't feel like you're getting scientific work done. It doesn't feel like that's actually needed for you to publish your results or get it disseminated into the community. And so the question is why? Why are you going to do that when what it does is help somebody else use your data, but you're not necessarily getting credit for that? And so I feel very strongly that we need to call these concepts out, because when we're building infrastructure and we're thinking about how to design both the software and hardware infrastructure, as Vivian said, for this community, we need to think about how people really work. And if we want behavior to change, we also need to think about the incentives that are going to drive changes in those behavior. And one last comment, Facebook has, hundreds of curators on staff for what I could potentially argue is simpler data than what we're trying to understand and reason about and curate. And it requires a different skill set to be able to hire those hundreds of people. We need a corresponding number of hundreds of scientists to actually help curate all of the metadata for legacy and future data. and to help build these systems like Tim is talking about to help with metadata assignment. And I don't know where that funding is going to come from or where you're going to find these volunteers that are willing to spend years of their career making data usable by others. So with that, I will pass back to Kevin.
Great, Kirsten. Thank you so much. Let's swing up north. Has dawn broken where you are, Matta?
Yes, indeed.
Oh, well, wait, that's great. So Matthew Trunnell needs little introduction to this audience. He's also been a fixture at the BioIT conference from many years at the Broad Institute and then at Fred Hutch. And I'm not sure, Matta, that everyone watching today heard your talk yesterday. So there may be some points in that you may want to briefly reiterate. But anyway, great to see you, and give us your thoughts from the Seattle Trench.
Excellent. Thank you very much, Kevin. It's really an honor to be here with everyone. And I have to admit, looking at your, fourth book now there over your shoulder, I feel a little bit like I've been standing still for the last 10 years that we've been in this space. As Kevin mentioned, I spent a long time at the Broad Institute working in kind of that research IT space, and then at Fred Hutch. For the last 4 or 5 years, I've really been increasingly obsessed with data commons as a construct for intramural and extramural data sharing. In the cancer space, with many of the questions that one wants to ask, it seems pretty clear, at least to an IT person, that no one institution has enough data to answer those questions really robustly, particularly when we're starting to bring in these statistical approaches like of machine learning to bear on these. So I've really been interested in this idea of cross-organizational data sharing. I left Hutch early this year, actually just before the COVID excitement started, to spend more time in between organizations looking at this idea of sharing. So really my trench now is not mine. I'm spending time in other people's trenches. And this has been an interesting experience. So a couple of comments about data sharing in general. First of all, we've been talking about it in our space for a long time. I was really kind of, 2 or 3 years ago, pretty frustrated because it felt like we were having the same conversation over and over again about it's too hard and incentives aren't aligned and all that. But I have to admit that over the last handful of years, even before COVID, and I do think COVID's an interesting driver, that we're seeing progress in this. This concept of fairness is starting to take shape. There's some exciting trans NIH efforts that are being driven by Susan Gregorek and others to start to wrangle data assets across the institutes, which I think is really exciting. There's a tremendous amount of work to do there. It's not an easy task, but I do think that's hopeful. I think too, we're seeing data sharing in other industries that we probably don't pay enough attention to. So there is a large amount of business-to-business data sharing that's happening in ways that have privacy concerns that, while they're not the same as we deal with in human subjects, are still quite relevant. So this might be, for instance, Uber sharing ride data with the jurisdictions in which they operate, and in these other business-to-business data sharing aspects, I think a lot of progress is being made, and some interesting technologies are coming to bear. So there's a relatively new cloud-hosted database technology called Snowflake. Snowflake, about a year ago, created a VP-level position of data sharing. And I think that's really indicative of the industry starting to take, the industry at large starting to take a view of this. We're not there yet in the biomedical space, and there are a number of reasons for that. But as Kirsten and others have pointed out, COVID has been a fantastic driver. Like, we don't have the same urgency in other diseases that we've had in COVID. And COVID has driven some exciting actions, both at the national level. So NIH has a couple of projects going. I've been working in a project kind of in a more regional focus that's pulling together data for research activities. I heard a quote saying that, yeah, it's great that we're doing all this for COVID, but we still have all these other diseases that have been grandfathered in, like cancer. And it's my hope that we can bring some of this organization and alignment forward from what we're doing, starting to do now in COVID, and bring this into some of the other disease areas. So that's my area of interest. Sorry about that. All right, that's all I will say.
Thank you, Matta. That was great. So we'll bring all of our panelists back now. And I think they can probably all go on camera, or because we're just going to have a conversation. And but each to their own. Chris, I want to get you back as well. Was there anything there that you heard that you'd like to respond to immediately, or anything that you're seeing in the chat that you've been monitoring? Because I've got about at least half a dozen great audience questions I want to get stuck in.
Nope, I'll defer back to you. Well, let's take the questions as they come in.
Right.
I'm done pontificating.
Oh, well, there'll be time for that too, I'm sure. So, okay, thank you for the questions, everyone. Use the chat or use the Pathable chat if you want, but I'm going to plow through these half dozen. And in some cases they're for specific panelists. In some cases it's like an open question. Gabriel was the first to chime in. He said, I'm assuming it's a he, I'll be really curious to hear the panelists' thoughts on the tensions of facilitating experimentation in data science, models, feature engineering, and plug and play aspects of open software and science with enterprise goals such as reproducibility, provenance, and other aspects. What sort of approaches are you using to support both goals? Vivian, would you like to start? Should we go in order?
I think you're muted.
Yep,
Right.
Vivian, you're muted.
Sorry, I couldn't quite hear your question. You might have to repeat it, Kevin.
I'm happy to, yeah. Gabriel asked, Gabriel is curious to hear your thoughts on the tensions of facilitating experimentation in data science with enterprise goals such as reproducibility, provenance, and other aspects. What sort of approaches are you using to support both goals?
Trying to understand what he means by the question is in the sense that you've got experimentation, but also have enterprise systems. I'm trying to parse that question a little in my head. If that's what you're trying to ask, help me out here, Kevin, if that's correct.
Well, I can only go with what I'm seeing. So why don't I throw that open to anybody else? Would anyone else like to take that?
I'll have a little punt.
That's fine.
That's a challenge that Sanger has been having, because one of the things that's really changed over the last couple of years for us is we've gone from being a place where we did sequencing on a large scale, but it was entirely for our own internal research purposes. And one thing that's really changed in the past couple of years is that we've started doing things for other people on a large scale, which brings with it that sort of commercial and enterprise requirement that really wasn't there before. And I have to say, I've kind of taken the coward's way of dealing with it, which is to basically say, I've created two sets of infrastructure. There's one set of infrastructure for the experimental playground, and there's one set of infrastructure for the public, for the production world, where we're doing the UKB sequencing, for example, the whole genome sequencing for UK Biobank, and that does not get touched. There's no experimentation there.
Right, I can jump in, Kevin. So,
go ahead, Vivian.
Yeah, so what I'm seeing in government organizations is there's a tension between those two. And when it's not addressed, you continue that tension. When you do address it, what you're finding is kind of like a sandpit place to play. But organizations are realizing that they also need robust things to work at scale and be reproducible, etc. And so creating those sandpits for those folks to do it has to come from the combined leadership agreeing to that, and the organizations that are choosing to do that, that works. Some government organizations, particularly those that are purely academic, I think There's still a very strong support for academic research, which is fantastic, but it doesn't tend to lead to some robust solutions. So I think that tension exists and that question needs to be asked. The solutions in my mind come again from the organizations coming together with all components, the IT, the science, the leadership, all coming together and realizing what those needs are and allowing that place to play. And lastly, I'd like to say that you need that space for scientists to play. That's what they're interested in doing, and it creates dynamic change. The organizations that get dynamic change and allow that are the ones that I think are going to produce some pretty interesting work from that.
Thanks, Vivian. Anyone else want to have a take on that? Kirsten?
Yeah, I mean, I agree with what they both said. I just want to throw out a kind of subsequent challenge that potentially exists.
Yeah.
And that we've talked about how the data are getting produced in a distributed manner, that we potentially have distributed data repositories. And I think some of the work that's needed is kind of exploration and playing with all of that data. So what's the right software and hardware infrastructure to meet that use case so that it is a space where it can be responsive and interactive? And that's something that we've grappled with a lot in the national labs and the Department of Energy. We have really amazing compute infrastructure for large scale jobs and exascale where you submit one job, one code to use thousands of nodes. But the flip side, the polar opposite, is having infrastructure where somebody can log in and interact with the data and have all of the compute that's needed behind it. And so that I can see how to do it when you've got your storage and computing co-located, or potentially if you're using something like the cloud. But in this model we're moving toward, we have all these points for data generation. What are we going to do to create that interactive exploratory sandbox, assuming we've actually done all the work to make it possible for those data to actually be integrated together, which is a different problem.
Okay. Matt, anything you wanted to add? If not, I'll move on.
No.
Okay. James has a question for Chris, going back to the trenches talk. Chris, what sets one good data lake environment apart from the dozen or so that are not so good?
Yeah, I think, data lakes can fail in a couple of different ways. The two failures that I've seen, relatively recently in my career, one is sometimes they can fall apart under just getting the security and governance bits in place. If there's certain data files that can only be unblinded to certain people, managing that sort of role-based access control to data can be very problematic if you don't have an operational plan to sort of manage and sustain that over time. But the second biggest failure I see for the data lakes is, this is enterprise and corporate in particular, where companies have an easy time rolling out new capabilities. They have a hard time rolling out training and operational support. Either they don't do it at all, or there's a big push for the first 2 weeks when you sign that expensive contract and you roll out, I'm not going to name a vendor, but you roll out the platform, you spend a couple of weeks doing knowledge transfer and training. And then after that, there's literally nothing. And what you find is that over time, there's just sort of decreased lack of use. New early career scientists come on board. One of the things that we've seen is when you roll out major sort of capabilities in a research-oriented organization, there really needs to be a significant investment in knowledge transfer and sort of sustenance methods to sort of keep those things accessible and usable. And I would say it's relatively rare for me to find a company that spends a lot of time training when they first roll out. It's almost impossible to find a company that actually makes a long-term investment in sort of ongoing training and operations. Then the other thing I would say is the other reason data lakes fail is that someone in the executive suite read it in a magazine and decided they needed one, and it's just rolled out and it's useless because it wasn't really put together with any actual outcome in mind.
Any comments or reaction to what Chris just offered? Okay, let's move on. Chris, you forwarded a question that came in via Slido. How do you start those difficult conversations between management, scientists, and IT about the tough love approach to data management by their producers? This got a big reaction, I noticed, when you touched on this in the talk.
Yeah. The funny thing is that it's actually fairly straightforward to start those conversations. I'll go back to some of the conversations I had way back in the day when I realized that when I was speaking with scientists, their mental model of a cost of 1 terabyte of storage was related to the fact that they went to Best Buy or Costco and they saw a 1 terabyte drive on sale for $60. So in their mind, a terabyte of scientific data shouldn't really cost it's a $60 item. And so what we did is we sat down and we had the honest conversation with them where we showed them that, look, this is the system that we're using. It replicates, it's backed up. The true actual cost of providing you a 1 terabyte of scientific storage over its full life cycle is closer to $10,000 or $15,000 a year per terabyte. I mean, obviously the prices have crashed recently, but the thing is, scientists are smart. They want to be team players. They're really engaged. But for me, it was just the conceptual difference. To them, the cost of a terabyte was what they saw on Amazon or Best Buy. And so the first step in the conversation was having just the honest conversation with IT being more transparent about the fully loaded costs of providing the services that they haven't really thought about. The second thing, and this is where the tough love comes in, is that it used to be, 10 years ago or 5 years ago, it was just a budget, question. Oh, if we spend 30% more, we can give you the space you need. The fact is now in 2020, we literally cannot give you the space that you need. Like I said, there are very valid scientific reasons why she might want to bring in, 30 petabytes of, UK 4K or other large scale data. And so now the conversation turns to an honest conversation about the cost, but also an honest conversation about the actual limits of what IT is capable of providing. And that translates into a conversation with scientists about how would you prioritize your research? What are the most, what are the most important questions that you want to ask against your data? If we had to triage, or if we could only fund 50% of your requests, how do we do that? And the cool thing about that is that feeds into helping set up a sort of governance or storage communication or storage management process where you really do get that nice interaction between science and IT. But I think my long-winded way of saying it is that first you're honest about the costs. And then the second thing is you have to have the honest conversation with them about, look, we can't even throw money at the problem anymore. We literally have to triage and put quotas. And so as soon as we talk about quotas, we have to have that conversation with the scientists about, prioritizing based on business value or scientific value and sort of, moving on from there. Generally speaking, once those conversations happen, I've never had an issue dealing with the scientists. It's just, starting that conversation kickstarts a lot of sort of positive interactions down the road, ideally ending up with a governance committee, they're responsible for and managing that data.
Thanks, Chris. Any other reactions?
Yeah. One thing I'd like to mention, I completely agree and have long applauded Chris for saying this is not an IT problem to solve. But for organizations that are really large-scale data organizations, particularly those that are interested in machine learning and AI, it's probably not an individual lab's problem to solve uniquely also. That there's room to invest in new capabilities in organizations, and I would call this data engineering or data analytics, which probably doesn't live in IT, but can play more of that active role. Kirsten mentioned the data curators at Facebook, right? That plays more of an active role, the hands-on role in managing data on behalf of the organization. That becomes the tactical part of data governance. And I think that we're going to see more of that, either being developed within IT organizations or in the couple of places that I've worked, developed outside of IT organizations.
Okay, thanks very much. Let's move on to another question. John wants to ask, or does ask, weaving together the past two plenary sessions, is there potential in leveraging citizen science for metadata curation efforts, or is it too reliant on subject matter expertise? Who'd like to take that? Don't all shout at once. Kristen, go ahead.
I think it's absolutely dependent on subject matter expertise. And we have an even deeper problem where, so I come from the environmental space, which I think is a little different than a lot of people potentially in the audience and potentially on the panel. So we are studying microbes and plants and fungi and things that have no expectation of privacy, which makes, on the one hand, that a little bit easier because we don't have HIPAA constraints, but on the other, there are folks out collecting these samples in the wild, and if they don't collect some key pieces of metadata in the moment, there's no way you can add that back later. So imagine you're coming to this system and you're asking a question, you have your favorite organism, and you say, I want to see all the places where this organism has ever shown up, this microbe has ever shown up. And to do that, you have to be able to tie that back to the metadata from the sample itself. So it's not just enough to be able to go through and curate the data themselves that have come out of the sequencer, the digital objects, we also need to maintain that sort of line of provenance all the way back to the study that was done where somebody went out and collected it in the field. So that's really challenging. And I think you have comparable things when you're looking at host-associated data. And so it's hard. And so I would argue that like there's that where you can't reproduce it. And then you do need to have some scientific knowledge to look through and sanity check some things. But then there are also more extreme cases where you could look at a map of things that are meant to be, say, plant samples or taken from a human. And if you find corn growing in the middle of the Pacific Ocean, that's probably got some mislabeled data that people could probably correct. And so there is the whole spectrum of potential things that we can tackle and fix. But I think it's going to take the scientific community, and we can't just hire anyone to come in and kind of help us make these data ready for AI and ML and statistics.
I'd like to take a crack at that too.
Go ahead, Vivian. Yeah.
I totally agree with Kristen. I think that's exactly, you definitely need subject area expertise for all the reasons that you described. I think that's consistent also with the human data that I've dealt with. But I'll add another one, especially this is my experience of what I saw at NIH, working with multiple groups that did do this. They wanted to engage citizen scientists. You needed the subject area expertise. They had different levels of which people could actually contribute information. The problem becomes incentives too, particularly when you want to engage in the subject area expertise. I think Kristen brought this up in her presentation and discussion before. When there's no incentive in the system, people will not spend hours and hours and hours of their time doing it because data is not incentivized for their career, it's the paper. So we have to change those incentives so that people who do this data curation are as important as getting the paper. So it comes down to data citation. It comes down to the citation of our data and software, not just the papers. When you do that, I think you're probably going to get more of the subject area expertise involved that we sorely need. And in terms of the citizen science, maybe when there's more incentive for those folks with SME experience, the subject area expertise, there's going to be more incentives for the communities to come in. What I have noticed for the ones that have done this is you've got to be careful about the level of curation you bring in. People that are very interested but don't have subject area expertise can bring something, but you have to be able to parse that out. So some of the systems I've seen is they have different levels of curation, but that in itself requires a lot of work from the groups that are already doing that work. They're often not given much funding to do what I think Tim was saying before, which is training, or Chris was talking about the training that organizations roll out. It's like, here's this brand new thing, 2 weeks of training. What we need is much more respect and support for training, rolling it out, and people to be able to see the incentives of being able to do data.
Thanks, Vivian. Anyone else? Lots more questions coming in. If I don't see a waving gesticulation of hands, we'll move right on. Matthew, a couple of related questions for you, please. I think these come from different people, but they seem to intertwine. What tools and other software do you use for data sharing between organizations, both intramural and extramural, particularly for cancer, apart from data commons? And related, what's the best platform that has all the cancer data in one place that you mentioned?
Well, I think that's the aspirational goal. So I do think, you know, we're seeing some interesting technologies develop in this data commons or data platform space. Chris had mentioned Gen 3, which is a system that evolved from the platform that's supporting the genomic data commons for the National Cancer Institute. The data sharing piece, I don't think I've seen a really good solution for yet. Not from the pure technology standpoint, because there are ways to do that, but it has much more to do with the governance aspect around who gets to control access and permissions. And that again, is a place that most organizations aren't really good at thinking about. Like, until you've developed some muscle around data governance, those questions are hard to answer. So there are some technologies out there that can do that, where you can delegate access controls across organizational boundaries. But organizationally, most groups are not comfortable with that. So in terms of where are all the cancer data, they're not all in any one place. I will note that NCI is doing a lot of work towards what they're calling their research data commons to bring together different types into somewhat more of an ecosystem. But there's so much more work that we have to do as a field to get to the point where we can really leverage each other's data in cancer.
Tim, do you have thoughts on that? The Sanger has done a fantastic job generating some brilliant cancer data over the years.
So actually, my main thought about that is that we are in the extremely fortunate position of having the EBI on the same campus. So long-term data publication really goes through them. We have a nice synergistic relationship with them. So, you know, we are largely the data producers, but actually, generally speaking, they're the ones who look after the data for us in the long term, or at least that's certainly the way it should work. I mean, of course, we tend to keep a copy of it ourselves as well, which is, you know, exactly the sort of problem we've been talking about. But in theory, that is the general data flow and the way it works. So I kind of dodge the problem to some extent.
The dirty linen is coming out now. All right, let's move on. What's another question? Somebody would like to hear more about the challenges of migrating to a project-based data management structure and how to overcome. The challenges of migrating to a project-based data management structure and how to overcome. Anybody?
I can start, I guess.
Yeah.
Yeah, I mean, I think, you know, definitely this is a policy and communications thing more than it is a technological fix thing. So you start out first, and absolutely, you might actually have to bootstrap a governance or a data management committee, because again, the thing that I really want to come back to is, and Matt alluded to it as well, is that it's inappropriate for IT to be making scientific data management decisions. You know, so the source of truth needs to come from the science side. So it starts with communications and policy and sort of earning a good trusted relationship between science and IT. And then where the sort of rubber meets the road is the implementation side is, you know, you might start deploying quotas for the first time, and scientists are going to start running up against a quota, and you might find that the quota in the space that they've used, and basically what you do is the carrot and stick thing is, you take the quotas off on the archive tier, the nearline tier, the project tier, where you want them to move their data, and you sort of incentivize themselves to sort of move, manage, organize, and tier the data out. But again, I think that the real focus is human to human communication and policy more than sort of technological fix. And where the technological fix really, it's things like quotas, automated transfer tools, and sort of good operational knowledge, and sort of helping them sort of move and reorganize.
Any other reactions to that?
Yes, yeah, a little bit.
Vivian, then Kirsten.
Oh, sorry, Vivian.
Go Kirsten first.
Okay.
Oh, wait.
We're so polite. I just wanted to say that when I started at the Joint Genome Institute, this was absolutely an issue about 8 years ago. There was one storage system and there were no quotas on the system. And because of the growth of data, suddenly the storage system was full. And once, the other thing to Chris's point about quotas is, depending on the file system that you have, once people start hitting those quotas, you can also see performance issues on the system, which gets to be extra fun. So this actually inspired the organization to put a data management system in place to help the scientists and to help the staff automatically archive data. And to what Chris was saying, this was done on a project basis, with the scientists being able to inform the lifetime that files got to stay on the file system. And this was in stark contrast to what NERSC, the supercomputing facility, wanted to do, because they had very fixed policies for when data would get deleted from the system. But there needed to be some sort of meeting in the middle where there could be space for long-term projects and then space where things got cleaned up more rapidly. But it took a lot of social engineering to make that happen. But at the end of the day, I think it wound up working much better.
Vivian.
Yeah, so I just want to agree with what Chris and Kirsten both said about quotas for a project, but I want to also provide a slightly different perspective. So I'm actually working with two small nonprofits that, when they tried to look at their entire problem, everyone saw it from different angles, and it became a very challenging conversation. So what folks did was they came down to essentially looked at a project with only 1 or 2 data sets, of which they brought together scientists and IT folks together for the reasons that Chris was talking about, and actually almost start from a blank page. because when they tried to look at the whole thing, it was too difficult to digest. And if you looked at certain data sets, there were just too many antibodies around them. So by picking a sort of a low antibody response set of data and actually bringing the people together to discuss it, including the leadership, they actually started thinking about this from a more holistic perspective, and they started working out a data governance model where all people had some discussion, but it was small enough that they could actually test it out in a project-based environment. That project is just underway at the moment, and people are having aha moments from it because they're realizing it's not always about the technology. And if both folks from each one of wherever their fields of interest is can step back and listen to the others, that is actually where the project is making a lot more progress. And what they're noticing is that it's both meeting the IT, the science, and the leadership needs, and they're all being informed. And we're starting to see little glimpses of that. One of the questions that I saw coming up there, how do we, there's a question around flipping around the other way, which is, can you give examples of organizations that do that? I can't speak specifically to the organizations for many reasons, but what I'd say is when you've got each one of the personas or people that are responsible for elements within an organization able to come together and willing to have those discussions, that is generally where the best places are to start with these kinds of conversations and then solutions.
Thanks.
I could probably say something to it as well, if I may. So there are two things that occurred to me about this. So we are going through this particular pain at the moment, as I said. One of the things that I've found particularly useful was that having done the sort of survey of where we are and revealing, looking under all the rocks and finding all of the nasty things, was to actually then to have a series of meetings with individual faculty scientists and say, look, we found these gaps, but also what is it that you want this to look like? What are the problems that you have, with your data management? And it turned out that actually most of the things that they had trouble with were things that actually moving to this project-based thing would solve at a stroke. So, the single most common complaint I had from every faculty scientist was, when my PhD student or postdoc moves on, I don't know where that user's data is. Yeah, well, okay. Yeah, well, if we put it in a project, you'd know. And so actually, they kind of argued it for themselves quite successfully. So I was quite pleased with that. What was the second thing? I can't remember what the second thing I was going to say was. So I'll stop there. Okay.
I've got a great question here from Alex Bangs. It's a blast from the past. Hi, Alex, who's been part of the BioIT community since the very beginning. Alex asks, flipping the question now, are there model projects or organizations that are getting the governance, curation, and metadata annotation right? And why are they good at it? Thanks for the question, Alex. Who'd like to take that? Who's got something good to say about an organization?
I can't name anyone in particular, but I will say that where it starts is that it's relatively easy to train up a data scientist or an analytics person. The real value is actually not those skills, because those skills can be taught or learned. The real value is starting with someone who fundamentally understands the data and understands the data that you're working with. And so for me, the successful projects start with an assumption that subject matter experts are involved from day one, or at the very least, the people we have involved in planning and rolling out this project truly understand the domain, understand the domain and understand the data. I keep coming back to data science skills can be taught. Data domain and scientific knowledge, that's the valuable stuff. And I think that's really the sort of start of the sort of successful, like I said, I can't name the successful ones, but that's kind of the seed. I think it's you start with these subject matter experts.
Can you give us a clue?
Too many NDAs.
I saw one very good one. This is actually, it kind of speaks to what Matto was saying earlier about there being good examples in other businesses. A couple of years ago, the EBI brought in the BBC to give us a talk about the way they do their data management for, in particular for journalism. And I was absolutely amazed by it. It was fantastic. They have really good tools so that when the journalist is writing their article, they tag it with the appropriate metadata. So if they're doing a story about the Hull versus Southampton football match, it's tagged Hull, it's tagged football, it's tagged Southampton, and then it just automatically appears, of course, in the appropriate news pages for the right things you're interested in. And I just thought, wow, these guys have actually really sorted this out. They've actually got a really good system going here.
Thanks, Tim. Everyone, yeah, Matthew.
In general, I don't know that in the biomedical space, I've seen it solved really well organizationally. It tends to be project-based. And some projects do this really well, whether that's ones that have an explicitly funded data coordinating component or just well organized. I think one of the ones that I'll toss out just as an example that I'm not at all involved in, but I think has been really impressive in what they've done is the Ncats Translator. So this has been working to try to solve that hard problem of sitting in the middle of a bunch of different data resources and make them work together and do that across organizations. And I think that's a impressive project to look at.
Yeah, I want to add to that. I agree with that. And in part, the reason for that is because the approach was also taken about the sociological approach about what are some of the issues you have to look at. And when you do that, I think that's why you get a better solution. So back to the question you were asking, Kevin, that was asked by one of the panelists, what are the organizations like Chris? We have NDAs, so I can't speak to it. But what I was saying before, and just to re-emphasize that, when you've got both the scientists, the subject area experts, the IT folks, and the leadership coming together and realizing that doing the same old thing is a definition of insanity, right? And it kept not working, it cost too much money, and they realize they have to make a change and they have to work collectively together and work collectively on a solution. Those are the organizations that I've seen that are making change, but they have to do it by working together as a team. And what Kristen was saying before about team science, that is critical to solve it. Many of the technology things are there. So I think when they're coming together inside their organization to solve it as a team, and they don't try and bite off more they can chew. So I think what Tim was saying about projects is really critical. What is missing though, and I think this goes back to what I think many of us have been saying, is there's still, certainly in the biomedical space, lack of incentives for the data piece itself. So we need to change that discussion of it's just the paper. It's got to be about other issues as well. I think when we do that, the combination of team science and different incentives in our system will mean that hopefully we'll get more organizations capable of that. And the effect of that is if we have good organizations showing that and being able to do that and having valuable outcomes from that, then those are also going to connect amongst each other, and hopefully that will have a domino effect in the positive sense here.
Kirsten, did you have a comment? Kirsten?
You're muted, Kristen.
You know, my headphones are working periodically. Can you hear me now?
Yes, we can, sure.
Okay, so that's fun. I love the IT challenges of life. Anyway,
Zoom and headsets. It's amazing, isn't it?
So I think you can do this well kind of in the moment, but one of the things I wonder about biology, and this is a question out to the audience and to the panelists, is like, do we have a good enough understanding of how people want to use and search through data to actually imagine how we would build a system like the one Tim described? Because that sounds so cool, right? And when I'm looking at it from the perspective of the JGI, where we are dealing with plants and fungi and microbes, like each of those program areas kind of has different aspects of the organisms they're interested in, and we're trying to think about common metadata or common things that we could use to drive like how, because it's not just about storing and stashing the metadata now, it's how people are going to use it, which gets to what Vivian was saying about these sociological issues. If you can understand the use now and potentially try to predict the use in the future, that should help with the design of the system. And I think we're pretty good actually at thinking through the use cases in the moment, but the systems need to kind of adapt as we move forward. We need to be able to update and curate the metadata and do assignment in the future. And so it really is a rich and interesting space where I think we want to collaborate with our engineers and our computer science friends to help us solve it. But I'm curious, like, do you think we have enough information now to where we could think about a BBC-like system for biology?
Tim, do you want to quickly respond, and then we'll?
My crystal ball's not very good, because so I don't know what the metadata is that's going to be important in the future. But I was just thinking that maybe that does, it fits also in with what Chris was saying about the cleanliness of data that you also need for ML and AI, because there's a similar question there, isn't there? What metadata do you need to be gathering with your, so that when you do apply a machine learning algorithm, you can spot when you've got some sort of false relation, oh, I've actually, which one particular instrument was doing something a bit strange, or it was a different. How deep down that rabbit hole do you go? Do we record which batch number of reagents we used? It could be a nightmare, but but that's sort of. I think we have to be pragmatic and say there's a certain amount that we know that we can store, but I think we're not going to get it right, and we just have to do our best, I guess.
Okay, we're coming close now to the end of our time, and but I want to make sure we get this question in from a gentleman named Stan Gloss. I know I've heard that name somewhere. It'll come to me. COVID, Stan says, is helping drive data sharing. Will our community revert back to our old ways once the threat is addressed? Look what happened, for example, after 9/11. What can we do to keep the momentum? Open question.
I think for me, it starts with what has been already mentioned here many times, in that the incentives are out of whack. There's I deal with people in government and other jobs whose entire career path is predicated on the number of publications they can crank out in a year. So I think the first thing that we can do is, if you want to address this post-COVID, we really do have to address the sort of micro and macro incentives for encouraging data sharing. And that starts with sort of figuring out the incentive structure inside the organization and then outside, and sort of figuring out, what can we do to complement this sort of already extreme focus on number of publications per year, which in many cases can encourage data hoarding over data sharing.
Other comments?
I will note that part of what has driven this current state in COVID is not just the urgency, but is funding opportunities. So new funding opportunities were created to make this possible, and that's something that one could imagine continuing in some form.
I want to echo what Chris was saying, which is you need to align incentives, because there are quite a number of examples where data sharing has shown new discoveries, but it kind of gets lost because the incentives in the system are still not aligned. So I think we need to definitely change those. And I think we need to consider how to do that now, rather than pretend that just examples of data sharing in the future are going to be the way to do that. And I think the time is for us to collectively strike, so to speak, in different ways to show the value in different ways along this entire ecosystem to make those changes. I think it has to happen at the government level, at the funding level, and the applications of all of the things that all of us are discussing here on this panel and also the conference into our projects. And I think the collective difference is what we have to push forward through.
Kirsten? Tim?
One last thing.
Yeah.
I will just challenge this panel and everyone who's listening then, like, we all sit in positions where we can make decisions and we can advocate for the incentives that we think make sense. I don't know how long, I haven't been in this field that long, but over the last 10 years, I have heard an incessant discussion around incentives and the need to change incentives. But I will bet everyone here, when you go to hire somebody, you're looking at their list of publications, you're looking at their pedigree, you're looking at where they got their PhD, who they've worked with in that network. And that's what's driving you to hire that person. And as long as we're doing it too, it's really hard to turn around and be like, hey funders, you should change. And I just want to echo what I said in the chat, we need to work together to decide what we think reasonable measures are. We can't expect the funders or the journals to figure it out without our input, but also there are things and steps that we can take to employ this day to day.
Tim?
I don't think I can add much to this. I mean, the Wellcome Trust tries very hard to, it has a very strict open data policy for all of our research. They are probably as good a position as anybody to try to enforce change through through funding bodies and so on. I mean, I have made this point up to, you know, I have occasional contacts with the Medical Research Council and similar people, but I don't want to overestimate my ability to influence them, to be honest. I agree with everybody that this is what needs to happen, but as Chris just said, we've been asking this question for a very long time, and it doesn't change very much.
Yeah. Matta, maybe I'll give you the last word.
Oh, well, I don't know if I deserve the last word, but you know, there are probably places that we can add value, and sort of going back to what Chris and Tim had talked about from the data management perspective, where step one is transparency. Like, this is what it costs us to do this, and therefore we can have a business discussion around it. I was blown away by an early demonstration of this N3C project that shows, is able to trace pedigree from a processed data element back through all of the open source packages that contributed to it, all of the source data that contributed to it, and produce a list of names of everyone that contributed to that analytic result. Like, that is compelling to me, and that's just a simple application of technology and being good about provenance.
Okay, I think on that note, I'm a little nervous that in 2 or 3 minutes, Zoom is just going to unceremoniously drop us out into a black hole, which would be unfortunate. And so I want to thank our whole distinguished panel, Tim, Matta, Kirsten, and Vivian, and especially Chris Dagdigian for yet another absolute tour de force. As always, a virtual round of applause. Chris, wait, I'm sure your slides are available. Do you want to just give a quick shout out to where we can find additional resources?
Yeah, I think, so I probably owe the slides to CHI because they'll be distributed to everybody who came to the conference. And then Stans really wants, BioTeam is launching a quarterly newsletter, which is supposed to be Trends-like. So if you subscribe to the Trends newsletter, you'll get the slides. But honestly, shoot me an email or find me on LinkedIn and we'll give out the slides as well. So many ways.
Okay. Well, on behalf of everyone on the annual Trends in the Trenches virtual panel, let's hope that we don't do this virtually too much longer. I'm not sure what the BioIT plans are for next year. It's probably too early to say because we just don't know the trajectory of the second wave or the third wave or the next pandemic. But let's hope we can get together in person very soon. But for the time being, thanks to everyone. Thanks to all of you for your great questions. Sorry to get to all of them. You know who to direct them to if you want to take them offline. So I think for now, we'll close this opening plenary session. Enjoy the rest of day 3, the closing day of BioIT World 2020. And thank you all so much. And please stay safe and vote.
Thank you very much, everybody. Bye-bye.